formed during the nitration of aniline. My question was that why the meta product is formed during the nitration of aniline, because since this one your this group means the amine group, they are only your ortho and para directing, yet also why the meta product is formed. That was my question yesterday, to which only two people have replied. So now you see my answer. This is your benzene to which your NH2 group has been attached here. And with this, when we are doing the nitration, the nitrating agent are nitric acid in the presence of sulfuric acid. When these two groups are added, these two substances, these two reagents are added, what happens here is that you will get two products. NH2, normal case is that they are generally ortho and para directing. Then you should get two products. One is this one, and the another one is this one, NO2, and one will be ortho, one will be here. But in this case, what happens? You will get three products, and your third product is a meta product. Meta product means NO2 is substituted at this position also. Now my question was that why this product? What is the reason for this product to come? Then here the answer is given by the anilinium ion which is formed by this benzene, by this aniline when it reacts with this acid. What happens is that this NH2, the nitrogen atom, it contains two lone pairs. These two lone pairs, they accept hydrogen from acids. So in the previous case, means initially this NH2 group, when bonded with a benzene in this way, then this donates its electrons towards the benzene ring. Then you will get negative charge here, this will be double bond NH2, this will get positive. Now I'm not going to draw it once again, this will go here, then this bond will move out, one negative charge will come here. Then similarly you will get at the ortho and the para positions, you will get the negative charge. But the case becomes different when this benzene, means this amine atom, it accepts an hydrogen. Means what happens, you see, when this benzene, the extra electrons which are present on nitrogen, when they accept hydrogen from the acids, since we are using acids H2SO4 and HNO3, these two acids we are using, and acids are those compounds which can donate their hydrogen atom. So if they are donating their hydrogen atom H positive, then these nitrogen, they can accept those hydrogen. So when they are accepting this hydrogen, they become NH3 positive. So now this, since it's already got a positive charge, it cannot give its electron more towards the ring. So now the effect becomes reverse. Now the electron do not move towards the ring. On the contrary, it moves towards the substituted atom. What happens? This will move to this place. Means earlier where you were getting negative charges, now you will get, means this electron will move to this nitrogen. So here you will get your N, H, and this 3 will be there, and this electron, they will move further to your nitrogen atom. This double bond will be there. Now here what will happen, the electrons are moving back to this place. Now earlier where you were getting negative charges, now you see this electron, it has moved from here. So now what you will get is that this carbon will get positive charge. Now to stabilize this will come here, then this will get positive, then when this will be positive, this will further come here, then this will be again positive. Means in this case, the places where you were getting negative charge, in case of anilinium ion, at the same positions you will get your positive charge. Means when it is your anilinium ion means NH3 positive ion, you will be getting positive charge here, positive charge here, and positive charge here. Then if these positive charges are present, you see where the amount of positive charge will be more. See, nitrogen, hydrogen, and hydrogen here. Now, one carbon is present here, one carbon is present here, and one carbon is present here. This carbon, since it is directly bonded, means it is near to this nitrogen atom, which is already electron deficient. One double bond, I misplaced it. This one carbon is present here, one carbon is, and one carbon is present here. Now you see, in all this one, the nitrogen atom, it is nearest to this two carbon. This carbon, with this carbon it is directly bonded, but the next two adjacent atoms are this carbon and this carbon. Means they, out of the remaining 5 carbons, these two carbon are the most electropositive one, because they are in close proximity with the nitrogen, which is electron deficient. Means the electron deficiency on these two carbon will be more. So here you will get a del positive value, here also you will get a del positive value. Now if you are comparing these two, the electron deficiency on this carbon, it will be less than this. So here the positive charge, it will be lesser, so that is why del positive. And similarly in this case you will get del positive. Matlab in charon mein, if you are comparing all the carbons except this one, the directly bonded one we are omitting here because ये direct bonded hai, so it cannot donate electrons to this one. The other two adjacent atoms, in these two adjacent carbon atoms, they are in close proximity to this nitrogen, so they will be more electrodeficient because they are near to the electronegative atom. But remaining all this, they will be lesser deficiency, there will be lesser deficiency, and this will be least one. Means here the deficiency is least, here it is more, and here it is most, means the deficiency. Now if deficiency is least, means this carbon is a little negative, and similarly this carbon is a little negative, and this is completely positive because here there is a deficiency. Though deficiencies are present here, but if we are doing the comparison, here the deficiency is least, that is why there are some sort of electrons present, and in this carbon also some sort of electrons are present. So here this negative can go and attack that NO2 positive. Similarly from here this negative can go and form that NO2 positive, that NO2 positive which will be from HNO3. With that nitric acid we are using, they can attack that NO2 positive, and you will get the two products. The major two products in these two cases will be your NH2, you will get one or meta product, and one you will get your para product. And these two products are your major products. Means if this one is suppose say some 41%, this will be 41%, then this will be 57%, and sorry, 50, not 57, I think 51 it is there, 51, and the remaining that ortho one will be only 2% in this case. So here the scenario becomes totally different for your anilinium ion or your amines. Why? Because in this case the anilinium ion that forms, it does not activate the benzene ring towards the substitution at the ortho and the para position. Rather, it activates it towards the substitution at the para and the ortho para and the meta position. Only this position and this position are substituted. The ortho product in this case, that will be only 2% here. That will be 2%. This ortho one, this is 47%. This is 51%, and this one is 2%. Means para one is the highest one because this is already symmetrical. I think this is already symmetrical, so this will be the highest, this will be the second one, and this will be the least one. The ortho product is the least one. So this was your explanation for the formation of your meta product in case of aniline. Now the another reactions of benzene, they are all similar to that ortho and the para directing groups. Means remaining all other reactions, whatever that you have experienced in case of your phenols, they will be all similar to this one. Suppose if you are doing the bromination, then also the bromine will be attached to the ortho and the para position. If the amount of bromine that you are using, that is more, then in that case you will be getting your substituted product in this way. You see, if this is your NH2 and if you are using Br2, then you will get two products, NH2, one Br will be present here, plus one Br will be NH2, one Br will be present here. Because here, since no hydrogen is there, so it cannot be substituted here, and so no meta directing product. But what will happen if the same compounds react with more molecules of bromine? 3 bromine are there. Then in that case, one single product will be there, and in that single product, you will get all the 3 positions substituted by your Br. In the single product, you will get there. Now, the all other reactions, they are similar to that of phenol. Now, the last part of this chapter is your that one, diazonium salt. Now, what are diazonium salt? We will see this. Now, what are diazonium salt? Diazonium salt. Diazonium salt. These diazonium salts, they are mainly those compounds which contain N double bond O. Now, those compounds which have this nitrogen-nitrogen bonding, they are known as diazo compounds. Now, in this diazo compound, you will never get any diazo compound like stored in a vessel or stored somewhere. Now, why it is like that? Because when a compound containing this type of, this is there, you see how it will be formed. Like if a benzene ring, if this is my benzene ring and this is bonded to nitrogen, then triple bond nitrogen, triple bond and triple bond N. So you see one of the nitrogen that is unstable, because this nitrogen is forming how many bonds? 1, 2, 3 bonds is formed by this nitrogen this side and one here. In total, this nitrogen is forming 4 bonds. So here this becomes unstable and it will have a positive charge here. So now we know that those compounds which have a charge on them, they are unstable. Now this instability brings a stabilizing ion near them. This is normally a chlorine. So this type of compounds, they are known as diazonium salt, and the bond formed between this nitrogen and nitrogen, that is known as azo bond. Now, how we are going to synthesize this? This is a very short topic here because they don't have much method. Means you cannot prepare them by many of the reactions. There is only one method for the synthesis of this reaction, and that reaction is using your aniline. When you use your aniline, this NH2, and when you are reacting this one with NaNO2, sodium nitrite in the presence of hydrochloric acid, then the corresponding compound that you will get, that will be your diazonium salt, where N2 will be there and Cl will be there. This N2 will have the positive charge and this chlorine will have the negative charge, and this product is known as your diazonium salt. Diazonium salt, they are colorless. They are stable only at lower temperature, because when the temperature will rise, they will go out, because this N2 they will go out as gas. So this is normally stable only at lower temperature. They are soluble in water. Why they are soluble in water? Because they have this type of charge in them, positive and negative. This type of charge separation is there, so they are soluble in water. Now here, these compounds, they are normally used as precursor of many reactions. Now precursor of many reaction means they are used for the synthesis of many organic compounds. This is the only method for the synthesis of your diazonium salt, and so this is the reason why this is important, because only method for the synthesis of diazonium salt is this one. And here the physical property and the chemical property, that is also not too much, because here they are only found in the lower temperature. When the temperature is lower, only they will be found, and they are found in solid state. They are colorless and they are completely soluble in water. Now their chemical properties, let us see. This chemical property, this benzene ring N2Cl, this is negative and this is positive. Now whenever you are going to treat this one with different types of compounds, suppose if you are treating with copper chloride in the presence of hydrochloride, then what will happen? This nitrogen gas, they will always go out. Means this azo bond, it degrades. Then what happens? It directly gets attached with the chlorine atom, and plus the nitrogen gas, it goes out. Similarly, if this compound, if you are treating with CuBr in the presence of HBr, means they are used as a catalyst, and this reagent will be substituted here, then here once again it will be like that. This Br will come here and that N2 will again go out. This is the reaction here. Further, if this one you are treating with CuCN, if you are CuCN, then in that case also it will be same here. Your benzene ring, that N2 will go out and this Cn will be replaced here, plus N2 will go out. N2 will go out in this way. So these are the different reactions for which, and also one reaction here, this the reaction of copper chloride and HCl. This reaction is a named reaction, and this reaction is known as your Getterman reaction. This is known as your Getterman, G-A-T-T-E-R-M-A-N, Getterman reaction. Getterman reaction. Now, similarly, different types of reactions are there where if they are reacted with potassium iodide, like you see, you have suppose I'm writing only R, N2Cl negative. If this one is there, and if you are reacting this one with Ki, then what will happen? This N2 will again go out, and you will get your Ri plus N2, and this is going out. And if you want this K and this Cl, you can write it together, KCl. In this way, you can write it here. Similarly, if you are forming a compound with fluorine, suppose Ar, aryl group, means that benzene group, this one, and this is bonded with N2Cl negative, this is positive, this is negative, and this one if you are reacting with hydrogen fluoride, this one, then what will happen? Fluorine group will be attached there. This one ring, one fluorine will be present here, and plus that Bf, and remaining compound, they will be the same thing here, the same type of compound. And if you are to replace, means if you are to convert a benzene into sorry, not benzene, if you are to convert a diazonium salt into benzene, then you are to react with any mineral acid. Mineral acid means this is your diazonium salt, N2Cl negative, this is your diazonium salt. Mineral acid means any inorganic acid. It be HCl हो सकता है या फिर H3PO3 हो सकता है. Then what happens? Only this is replaced by hydrogen, means you will get your only benzene. That benzene plus N2 gas will go out, and if you want, you can write further your HCl here. This is the product in this case. Means if they are reacting with these two, then this everything goes out from here. This N2 will go out as gas, and this fluorine will go out with that hydrogen, and this benzene, this is formed completely here. One more reaction is there. In place of mineral acid, you can also use an alcohol. Means if you have this N2Cl negative and N2Cl negative, if you are reacting with alcohol, suppose methanol, CH3CH2OH, then this case also you will get your benzene ring, and the remaining your byproducts, they are there. So this is the reaction. Now another reaction where the bond completely degrades, and the main reason, the main users of these compounds are that they are used in dye. That is, dye means the yellow dye, blue dye, or the black dye which are used in clothes, they are mainly formed this diazo compound. So when this diazo compound, suppose I have a benzene ring, the same benzene ring I am writing in the tilted way. Now here this N triple bond N, this is the compound, and here this Cl, this N is having the positive charge, this chlorine is having the negative charge. Now when this is fused with phenol, phenol means OH is there, and this compound, then we know that benzene, it is C6H6, so here one hydrogen is there. So what happens in this case is that this hydrogen and this chlorine, it goes out. This hydrogen and this chlorine will go out, and this bond, it will further move to this one. Then the final product will be your benzene ring and N. Now this triple bond, it will become double bond N, and this N, it will be bonded to this here, and you will get a compound of this type, OH. Now when this is fused with phenol, you will get the color. The color of this compound is orange. This is your orange dye. If the time allows, I will be showing you this one in the lab, that how this orange color comes here with the diazonium salt, and this is orange color. Similarly, you will have one more color, and that is a yellow one. In case of yellow one, the same diazonium salt, N triple bond N and then Cl negative, this one will be fused with your another molecule of aniline. NH2 के साथ अगर fuse करोगे तो what will happen? This is once again, this fluorine will go out, this benzene group is there, and then N double bond N, then another benzene group, and with that benzene group you have your NH2, and this dye, it has a color yellow. The previous one, this has a orange color, and the next one, this has a yellow color. Now from these two compounds, I say that we can use many precursors. Now if you remember that I have not taught you about the Sandmeyer's reaction in case of your formation of your haloarenes. If you remember, the haloarenes, you see, they were formed from this compound. This is your diazonium salt, N2Cl negative. These are your diazonium salt, and this one, when you are treating with copper and X2 is suppose any halogen, then what happens? This X goes and it replaces that N2, and plus N2 comes out. So this is the method for the synthesis of alkyl halide also, and this is your diazonium salt. So now if you are asked the uses of diazonium salt, so uses of diazonium salt are that they are used in dye, they are used as a precursor of many reactions, means many compounds are synthesized using these means these diazonium salt, we can synthesize many compounds. Okay, so this was your chapter where we came to know about the amines and we came to know about the diazonium salt. Thank you for watching the video up to here. Have a good day.